issue. Like so many issues where over the past 20 years, they used to be done by engineers and people way smarter than myself, they've become political issues that we bat around to make points. I'm proud to say that we're getting ahead of this one, and it's not a political issue. It's something that I believe can check every box that I have in my philosophy as a regulator. We know that grid enhancing technologies, that they can give us efficiency on our system, reliability. We know that in the long term, they can help save costs for businesses and consumers, affordability. We also know that it can help enable new and clean and renewable energy resources connect to our grid, sustainability. So that's what I hope we focus on today. I'll also say it's not lost on me that we're in Texas and that most of the western half of the country is under what's called a heat dome. That's a new term for me this year, heat dome. They hit you with a new one like every 2 or 3 years. But no matter where you fall down on why we are having extreme weather, this is clear. We continue to have it, and we as regulators need to figure out a way to solve for it. I believe that grid enhancing technologies can play a role with that. So with that, I want to turn it over to my co-chair, Kim Duffley, commissioner from North Carolina. I have to say, before she says it, I have tremendous respect for her. I'm so glad that I'm able to sit at this table with you, and I look forward to your leadership.
So I am talking now. Great. Thank you very much for that, Chair. I appreciate that, and I have an immense amount of respect for you as well, and I look forward to working with you over this next year. Like the last meeting, this meeting's set up a bit differently to provide a bit of level setting and education in the beginning before we begin our discussion about grid enhancing technologies, or GETs. These technologies clearly have a role and can be an additional tool in the toolbox. The question is, under what circumstances? What is the proper scale and scope of the consideration and deployment of GETs? I look forward to the discussion today where we may hear various perspectives regarding under what circumstances these technologies will provide benefit and enhance reliability. As Chair Phillips indicated, the composition of the N10 has changed since our last meeting, and I too wish to thank both Chairman Stanek and Chair Brown-Dutrell for their commitment to see that this task force succeeded. Chairman Stanek was the catalyst by gathering other state chairs together to encourage the creation of this task force so that we can strengthen our regulatory relationships and enhance the cooperation and collaboration between our respective commissions. After 2 years, it's good to know that he has accomplished his goal. We appreciate his leadership at the N10, and both he and Chair Brown-Dutrell will be missed. But we are also very glad, I see you, Commissioner Howard, we're very glad to have 2 new members from the NARUC region. We have President Joe Fiordaliso from the New Jersey Board of Public Utilities and Commissioner John Howard from the New York Public Utilities Commission. I'd like to turn it over to them now to make some brief remarks, and we will begin with President Fiordaliso.
Thank you, Chair. And a moment of personal privilege, if I may say hello to my good friend, Chairman Phillips. The whole macro region is so proud of you, Chairman. And I'm sorry I haven't seen you in public recently, but we'll get together and we'll have a Diet Pepsi or something together. How's that? Thank you very much, and I appreciate the opportunity. I've been on the Board of Public Utilities in New Jersey for 18 years, and I've been the president of the board. I don't know why they named it president. That happened well before me. And I've been president for 5.5 years. And it is an honor for me to be on this task force because from a parochial perspective, New Jersey is deeply involved in transmission issues, deeply involved in enhancement of our grid, deeply involved, as many states are, along the eastern seaboard and along the western seaboard in offshore wind. And my biggest fear, I think, is that we are going to have all of this great clean energy, and what Chair Phillips mentioned, and the reason why we need it, and he said that so eloquently. It's my biggest fear is that when we have it all ready, there'll be no place to plug it in. Then what do we do? And but I can assure you, we have to look at it and continue to put one foot forward after another, and do it on a regional basis, where we can work with our fellow states, our sister states, and make sure that the grid is sufficient, that the grid is capable of accepting the amount of clean energy initiatives that many states are involved in. I know New Jersey is, and we are excited about what we're doing, and so on. And as I tell my staff every single day, we've never done this before. We've never done offshore wind, as an example, before. So we're going to hit a lot of potholes. We're going to hit a lot of challenges. But I think if regionally we cooperate with one another on infrastructure, which we've been working on since Superstorm Sandy here in New Jersey, that we're going to be successful. And as the chairman said, the success is not going to be for necessarily me. I'm probably not going to be around to see the drastic effects of climate change. But I have 6 grandchildren who will be, and they're going to have children. And many here have grandchildren and children. And I believe we have a moral obligation to ensure the fact that we do everything humanly possible to mitigate the effects of climate change. And we will be judged on that by future generations. So this is one of the, I think, the reason that I am so happy to be on this task force. And I thank NARUC for nominating me on to this task force. And I look forward to working with each and every one of you as we move forward to make America better for all of our citizens, regardless of geographic location. Thank you.
Thank you. First of all, I want to thank NARUC and FERC for this tremendous opportunity that I really relish. I want to give a little bit of background for the New York context. In transmission development, planning, and execution, I believe we are full speed ahead. We have 4 distinct programs using every trick in the book. First of all, for the PPTN project process, which has been enormously successful, approving over 5 lines, 3 of which are currently in operation in a relatively painless manner. Go figure. And then, in addition to that, we have, I think we're leading the nation in high voltage DC transmission. We've approved 2, one from the Canadian border to New York City and one in-state New York. Additional to that, we've mandated AC utility projects owned and operated by our incumbent transmission owners. One to serve, to do reliability and decarbonization programs. And the second one, phase, will be to how do we connect large-scale renewables into the grid statewide. And in the offshore space, our first radial line is under construction in the Atlantic Ocean, and multiple radial lines are in the process of being permitted and constructed. And just recently, the New York ISO approved a PPTN project to integrate offshore into the broader grid. You know, these projects, I believe, are possible for 2 primary reasons. First, in New York, we have captive ratepayers required to capitalize the entire projects. And from my observation leading up to this, that seems to be a much more difficult process in a multi-state RTOs. And second of all, we do have a very cooperative, engaged, independent system operator. And clearly our single state ISO has tremendous advantages. And I don't know if it's replicable, but I'm glad we have it today. My hope going forward, as President Federico indicated, is where we go in the offshore space. I know it's not for today's discussion, but I think particularly important in the Northeast United States, it'll be really important for the FERC and other members, the help agencies of the federal government, to lead us to a much more sustainable and I think reasonable transmission system for offshore. Merely having a variety of radial lines will work in the short term, but it won't work in the long term. And by having a multi-ISO arrangements, we will, I think, avoid the overbuilding and certainly optimize our operational efficiencies going forward. And observing our friends in MISO and PJM, now's the time for us to do it. It's not after the projects are completed. For two reasons: planning will be much more difficult and retrofitting will be much more expensive. So, and as a background to all of this for today's discussion, we've included GETS mandates on all of our current transmission programs to date. And so I look forward to the discussion today and moving forward. So thank you.
All right. I thank you both for your comments. I can tell already your leadership will be an asset to this august task force. With that, Dr. Rapp, I think we are ready to begin.
Thank you. Today's meeting is organized in two parts. The first part, we're going to be doing some level setting and joint education around what the GETS options are, what the potential benefits are, potential risks and costs. And I'll talk a little bit more about that in a moment. And then for the second, which will be a longer part, we're going to be talking about planning and policy issues related to GETS, both that's for state jurisdiction and federal jurisdiction. Just three quick reminders before we start. One is that we have 10 state commissioners and chairs and now president. On the task force, there's 2 for each region. We're expecting you to represent your region, but you're also free to say things that are related to your state or your personal views, just when you're doing the latter, if you could just clarify that. The second is if you want to speak, if you just old-fashioned put the cue card up, I'll keep a queue. We have a way of dealing with the president and the chair who are remote on that. And then thirdly, if everybody could really speak closely into the mic, because I was getting a lot of feedback, and so do the kind of rock star thing, you know, keep it close. So with that, we're gonna jump right into the first panel. The way we have this arranged, we have a guest speaker, who's Dr. Andrew Phillips, who's the Vice President for Transmission and Distribution Infrastructure sector at EPRI. He's going to give a 15 to 20-minute presentation. We're going to have another 10 to 15 minutes of questions of Dr. Phillips from our task force members. And then we'll, to the extent we have more time, we'll start with a discussion. We have a few commissioners that will start that off when we get to that point. So without further ado, Dr. Phillips, if we can pull his slides up, and we'll let you just take it away.
Sure. Well, thank you. It's a bit of an awkward setup because the slides are behind you, gentlemen, so some of you will have to turn around. So
just keep the mic close.
Firstly, let me just make sure I'm not going to trip over myself here. I'm Andrew Phillips. I lead the T&D R&D at EPRI. And if you know about EPRI, the Electric Power Research Institute, our goal is to support the industry with science-based information to make electricity affordable, reliable, environmentally compatible for society. And that's our whole goal and objective. Today I was asked to talk about GETS technologies, and on Thursday we had a briefing for Andrew and said, Andrew, well, here are the things we want to talk about, and please add advanced conductors. So I've added on advanced conductors. I don't think this is advancing the slides, so if you could just advance to the next slide for me. In preparing for this fantastic event, I went and watched all of the briefings that commissioners you've received. And the motivation for GETS technologies is clear. The objective is, the reasons are there. I'm going to talk about them very quickly. When we looked last year at the cost of congestion across the United States, it was about $12 billion of congestion. And being able to resolve some of that congestion could save society an enormous amount of money, bringing lower cost generation to market. It could bring cleaner generation to market. And so using all the options that we have, not just traditional options, is vital for us. The other part, which is the right-hand side of my slide, EPRI's analysis to show that if society by 2050 is going to be net zero, it's going to mean at a minimum that we're going to move from the energy share of the economy from being about 21% being electricity, moving up to 39%. That's almost a double of what the amount of electricity society is going to do. Our analysis, which we think is pretty conservative, turns out that that means we are going to have to move from 100 gigawatt miles of transmission to 152 by 2050. It's a strange metric, but I'll just give you a different perspective. There are about 400,000 miles of transmission lines, 100 kV and above, in the United States. We've been building them at a rate of about 2,000 miles per year. We are going to have to double that rate to meet that goal, to integrate all of those lower cost and also carbon-free renewables. You don't mind popping to the next slide. So when, if you could move to the next slide would be great. Thank you. So one thing I thought that would be really good to level set that I thought maybe was not in the other presentations is, why are our transmission circuits limited? Why are they limited in current? And it turns out that there are three types of limitations, and those limitations are based on the length of the line in general. Lines that are 30 miles or less are thermally limited. That means that when current flows through the line, the conductors will overheat and they'll get above a temperature, and we've got to limit that. Only 30 miles and below are generally the lines that are affected by that. And technologies like dynamic line rating, technologies like advanced conductors can address that. Lines that are longer than that could be volt drop limited. Think about it, if you had a really, really, really long hose pipe, at some point the pressure at the end of the hose pipe is going lower and lower, right? And you don't get enough pressure. And so you can't take any more out of it. And so that's what we would call a volt drop limited line. And even longer lines are stability limited. That means if something goes wrong, everything goes unstable and the grid goes down. Also, we're not only limited by the lines. That's a bit of a misconception. We're limited by the terminals at the end, the substations, the transformers, the CTs, all of those things as well. And we're also limited by reliability constraints. If you go to the next slide for me, talking a little bit about advanced conductors. So what are these things, advanced conductors? So firstly, they address those thermally limited lines, those shorter lines. Advanced conductors are able to operate at a much higher temperature. Traditionally, conductors that we've used for a century are limited to 93 degrees C. Why? Because if they get any hotter than that, the conductor material starts changing and it could be damaged. Why? Because if it goes any hotter than that, it could sag down lower and maybe beat the clearance, the minimum vegetation clearance or the NESC clearance. Also, the connectors that hold them together are only rated to 93 degrees C. But there's this new class, and I wouldn't call it that new, but let's say a decade or more of conductors that can go to much higher temperatures. Those conductors, of course, will increase capacity now. There are multiple types. And when I was listening to the panels, the sessions before, they mentioned carbon core, but I wanted to say there are steel cored conductors, we call them ACSS, that can go to 250 degrees C, which use much more traditional methods for installation, maintenance, all of those things. And there are also aluminum ceramic cored conductors where they take powder metallurgy, 3M actually is the only person who does it. They take aluminum powder together with ceramics, compress it really hard and come up with this fantastic core. And all of those cores, when they heat up, do not sag as much, and the conductor can go to a much higher temperature. So you think, oh, golden bullet. But you know, with engineering, what you win on the swings, you lose on the roundabouts. And so there's always something that you need to take into account. If we go to the next slide, we need to think about the whole life cycle. It really can solve a lot of problems. It's an important tool, but utilities need to think about it from the acquisition, the operation, the maintenance, and the disposal. We don't know all of those things. And so for the last 10 years, EPRI has been doing tests on all of these new advanced conductors and developed a test that can be put into a specification so that utilities can acquire these conductors with confidence and knowing that they will last for 40 or 50 years. And that's a really important thing that not everybody knows. When a new technology comes to market, we need a spec to buy it to. We need to be confident it's going to last 30 or 40 years. And that's a really important thing and often a barrier. And really encouraging the manufacturers to work with people like EPRI to come up with those is important. I'm going to jump to the far right. I'm not going to talk about everything. But you know, at some point, those conductors are going to be 80 years old. We need to know how to inspect, assess them, and take them out of service. And so we are already starting now developing technologies to inspect and assess them. And that's really important. Thinking about not only this is a higher temperature thing, we can put it in, it's going to solve all our problems, but considering the entire life cycle. And so advanced conductors, to me, we have been working on it for a long time, acquiring it, very, very mature technology. If you'd pop to the next slide for me. Jumping onto dynamic line ratings. So I think it's a good idea to just start with what have we been doing for since 1930. Since 1930, we have worked out what the worst day of the year is going to be. 45 degrees C, wind speed's going to be really low, 2 feet, 3 feet per second of wind. And we've calculated that and said that's the rating of the line. You can't go over that. Even though it's the middle of winter and it's minus, 10 degrees C. Even though the wind is howling a gale, we assume that that was the rating. We were able to then say, well, it's different in winter to summer, come up with different ratings. So that was a good thing. But the advantages there is the planners that are planning into the future can use those values with confidence. They can use it for summer, they can use it for winter, they can really, really work it out. We're moving now, FERC 881, fantastic, to ambient adjusted ratings. That's when we change the temperature. We say, well, it's 20 degrees C today, so let's use that in our calculation. It brings in a bunch of challenges. The wind speed could be really low, and actually you could go below the rating, but we're working out ways as an industry to take these into account. And so today, we're getting extra capacity out of lines, or in the process of doing it, so that we actually can use what the ambient temperature is now, but not only the ambient temperature now, the temperature in 1, 2, up to 10 days ahead. Of course, the further that you go into the future from a prediction, the more the risk, the more the uncertainty, and you have to take that into account when you operate. So now to differentiate to dynamic line ratings, and sometimes people join ambient adjusted ratings with dynamic line ratings, but dynamic line ratings start thinking about the other parameters. They start thinking about the wind. And so the line is also very affected by the wind. And so if we can measure in the field somehow what the cooling of the conductors is due to things like wind, or the fact that the sun is maybe not shining and it's not being heated up by that, we could even get more capacity out of the line because we know it's being cooled. And so this requires a number of different approaches, but one of them is to somehow get field data back or to predict into the future the wind speed, the wind direction, and get a more aggressive would be the term I think maybe use, or more a higher value for the rating of the line, which will allow us in the market to bring in resources, okay, that before we would have had to curtail because the rating of the line prevented that happening. And so now we can bring in sources that are cheaper, bring in sources that are cleaner. Now, they come with their challenges, right? Nothing is perfect. And so if you pop to the next slide for me, once again, we need to think about all of the aspects. One of the challenges is there are so many different ways of doing this. It's a very relatively early technology. If you think about it, we've been doing conductors for 150 years. So now we've got something maybe that's 10 years old. And all of the different vendors, and I've put them up on the screen, I don't expect you to read them, but there are 12 different ways to actually do this. Now that makes it hard. Like if you're going to be somebody in a utility working out, like how am I going to integrate this? All right, which one's accurate? Which one's going to have a long life expectancy? How do I write a spec that for 12 very different technologies? Some of them use lasers, fantastic. Some of them use point measurement. Some of them use electromagnetic fields. And so they're very different, and that makes quite a few challenges, which will come clear to you on the next slide. If you go to the next slide for me, thanks. So I thought I would list what our members are saying to us. In transmission area, we've got about 70 utilities and ISOs who kind of get together and give us advice. What should we do? One of the big questions they have is, well, how accurate are these things? All right. Do we have a method to evaluate the accuracy, and a method that could be easily implemented irrespective of the vendor in a third-party unbiased way? Do we have a specification to buy it from? It's easy to do a pilot project where you don't have a spec and you can just buy it. But if it's going to become a day-to-day thing where we are going to incorporate these things, we need standards and specs, just like we've got standards and specs for transformers, insulators, conductors. We need one of those. We need that as well. The operators in the control room have to work out how to use these things. They are used to having a static number. They know how to deal with it. They know what the risk is associated with it. Now they're going to be getting a number that's changing. And that implies that the risk is higher, right? Implies directly that the risk is higher. Now that risk could be absolutely acceptable and not risky at all, but it's a challenge. And how do we come up with the practices and the procedures for the operators and change their mindset? Now, their mindset is fantastic in my mind. They are very conservative. Why are they conservative? Because you want to make sure the lights are on, right? You can't put up with one blackout per 50 years. We can't do that. So they're very, very conservative, but that conservatism is a challenge when you're trying to incorporate a new technology and increase the risk. It's slightly higher risk to it, right? Maybe a reasonable risk, but a higher risk. The planners don't know exactly how to take it into account. One or two utilities could do pilot projects or even a bit of an expanded project and come up with their own way, but not every utility needs to develop their own methodology. We need an industry-accepted way of evaluating these technologies, incorporating them into our plans, and then exercising those plans. And once again, one needs to think about the maintenance in the field. If we put hundreds of these out, these beautiful technologies out in the field, the maintenance department is going to need a whole new division of staff that are trained in electronics, that are trained in communications, that can get to these technologies and maintain them and operate them. And the asset managers need to know, what's the life expectancy? How much do I budget for failures? And there are a lot of people that have to be in that loop to work it out. Also, DLR by definition has computing power, by definition has communication, and you know cybersecurity is absolutely vital to us as well to take into account. If you pop to the next slide for me, I'm going to talk about advanced power flow controllers, which are also another technology. Not as easy to understand if you're not familiar with the power system, so I'm going to try my best with the diagram. You see a study that we did of SPP's power system, and at the bottom you'll see a little red cross. I can see it's tough to see from a distance, but imagine you've got this system and the 345 kV line flashes over. A bird, sits on the structure and defecates and flashes over. We need that the rest of the system can carry on operating, N-1 contingency. And it could mean in that case, when we did the study, that a 138 kV line, quite different part of the system, would become overloaded. Now, 77 miles of line would have to be upgraded. It would cost about $60 million to do that. But imagine if we could put a device in that would actually throttle or reduce or increase the resistance, which is not really correct, but increase the resistance so that electricity doesn't want to flow down that line, rather flows in the rest of the system, which can cope with it. We're actually increasing the impedance, to be technically correct, before somebody gives me too hard a time, and doing it. And these are power electronic devices that can kind of be put at the terminal ends of the of the line. Strangely enough, they're very similar to things called phase shifting transformers or regulators that we use already today, that are large electromagnetic devices. They look like huge transformers. And really, it's just a more advanced way of doing it, fast to procure, can be put in place, and maybe could solve a problem like this until the system is upgraded, and then move to another location or for another application. And during that period of time could enable more resources to come to market, right? And could solve a lot of problems. There are lots of questions. The biggest questions seem to be, how do I take this into account in my planning study? And is there a uniform way of doing it? There are lots of vendors saying, here's the studies. There's lots of individual consultants, but a known process that's industry accepted, that's well recognized, that is automatic, is just part of the thing. And I was very encouraged to hear, like New York State, Commissioner Howard, I think it has to be taken into account, right? And so when we say it has to be taken into account, the practices and processes need to be in place. The metrics to evaluate need to be put in place. The last GETS technology, I kind of, because of my time, did not put a slide together on, is topology control. And so topology control is really just software sitting in the control room. And it is looking at the network and saying, if I opened a circuit breaker over there, I would actually increase the capacity of the network because that line won't be overloaded and the rest of the network. But it takes a lot of computing power. There's an enormous amount of lines. You've got to simulate what would happen. And if all the contingencies are met, there's a lot to work on. And working out what the best configuration of the network is. Obviously, yeah, that's the advantages of it. Why the reluctance? Well, operators are conservative. And they're going to be relying on this computer to tell them what the best thing to do is. It also is not intuitive that if I take something out of service, I'm going to increase capacity and increase reliability. Like you'd think I should just have everything in there. But when you put everything in, something gets overloaded. There's some other little things that one has to think about. One of them is protection and control schemes that are protecting the grid, electronics that are measuring things. There's a concern that they may be, if we take the grid into a configuration it hasn't seen before, it may not operate the way we expected, and we're going to have to work out how to model that and work that out. And of course, we're going to be operating our circuit breakers more. So I'm an asset guy. We operate these circuit breakers more. Normally, they only work once every few months, maybe a year. All of a sudden, we're going to be switching them more, brings in more maintenance. Again, means more potential of something to fail. So pop to my last slide. And I think I'm just looking at my time. I think I'm almost at the end of my time. So if you could leave my last slide up, if that's possible, the one before that one would be great. No, that's perfect. It's perfect. I'm going to just focus with one thing that's interesting about all these technologies, and let's just say, apart from the advanced conductors, is how many people are in the loop to get it right. So, if you think about the old day of a rating of a transmission line, the conductor guy would work out what the rating is and he'd part it onto the planning department. The planning department would take it and write a memo and say, yes, you can use that, and here's the line design. And he'd give it to the, to the operators, and then he would look at it, and that would just be great. Now, if we're going to do that, we need to get the communications department in place, right? They have to work out how to get the comms in place. We have to get the cybersecurity department in place. We need the specification department or the procurement department to write the spec. The engineering department has to think about these dynamic ratings and how they're going to change and what the risk is, and give it to the planners, and the planners are going to give it to the operators. And now we've got a bunch of new maintenance. And I know that sounded a little over the top, but there are a lot of people that as soon as you put a piece of electronics and hardware and software, it becomes a lot harder. And in South Africa, where I'm from originally, you probably worked it out from my accent, we have a saying, which is, if you don't want to get something done, form a committee, okay? And I apologize to the committee for that. But it's really hard to get everybody on board. And I was speaking to some planners and saying, like, why aren't you taking this last week? Why aren't you taking this thing into account? And they said, well, we think the maintenance department we don't really know what their thoughts are. They're saying it's going to be too expensive. It's going to be a problem. And that puts, so breaking down those barriers between the silos, to make sure that people are communicating, it's harder, all right? And trying to get everybody on the same page. And I'll just leave you with that. There's some more points on the screen, but I hope that was interesting.
That last slide up there while we go to the task force members, commissioners, questions of Dr. Phillips. So he won't be here for the next panel. So if you have questions, this is a great time about anything he said or you were interested in. Chair Phillips.
Ask a question. Okay, so thank you so much, Dr. Phillips. I learned from your presentation. I'm reminded of something recently. There's a very well-known technology company, and what they do is when there's a new idea that comes to a manager, instead of reflexively saying no, what they're required to do, if they say no, they have to write a memo explaining why you say no. If you say yes, there's no memo. I think that's an interesting point to think about when you talk about new ideas. And the new idea that this company rolled out, because the person didn't say no, made this $1 billion company. But the question I have, I was one of those folks that wanted you to talk about advanced reconductoring. I talk about it all the time. And one of the critiques that I hear all the time is, well, this is just too expensive. It costs too much. It costs too much to implement it. So my question to you is, what would you say in response to a critique like that on the cost-benefit analysis?
It's a very good question, and to give you just a feeling for it, the cost of the advanced conductors is 2 to 5 times the cost of a standard conductor. But the cost of installing the conductor, you have to think about the total cost of installation. It's not just the conductor. Most of the cost is actually the field installation, all right? So one shouldn't be thinking just about the conductor itself. One should think about the cost of installation in the field and then compare it against what the other options are and the timeline in which those options could be achieved. And so if one takes just a purely cost-benefit approach where one compares the cost of this versus the cost of that, but one takes 3 years and one takes 30 years or 12 years to put a new line in, that needs to be taken into account. And but it still remains a cost-benefit analysis. But there are many cases in which it will increase the capacity and be cost-effective, is what we've seen in some of our case studies that we've done.
Christy.
I want to ask you about DLR specifically, dynamic line ratings. I think we have a general proceeding, so we can talk about that, right, Matt? And I think DLR sort of illustrates, there's a whole lot of gets, right? I mean, DLR is just one of them, but you talked about it. And it sort of illustrates the big question I've got about it, and that Co-Chair Duffley referenced this, is where and when do you use it? Now, with DLR, I mean, the D stands for dynamic, and that tells you that it changes, right? I mean, sometimes it's working, sometimes it's not. It's wind-driven. From a planning standpoint, how do you work in a dynamic, which by definition is a changeable phenomenon, into the decision in your planning, which you have to get right? How do you look at that? Because that seems to me that's really the big challenge in so many of these is we know there's tremendous potential. We know they can save a ton of money where and when they work. And so from a planning standpoint, how do you go about that?
Yeah, so that's really one of the issues that are brought up. Definitely from a long-term planning point of view, when one is looking, 5, 10, 15 years out, how can you predict what the wind's going to be in 5, 10, 15 years out, right? And so taking it into account from a long-term planning point of view is a really unknown thing. But if you think about it from a real-time point of view and not for a reliability point of view, just from an economic point of view, and one says we're going to use it real-time or maybe one day ahead, and use it to bring in resources that are more economic, all right, that are cheaper or cleaner, and bring them to market, that will work, all right? But one still has to plan for one's N1-1 contingency, and one still has to plan for the fact that the rating of the line will be the static rating. Because there will be a day where the temperature is high, and there will be a day when the wind is not blowing. And an interesting fact at EPRI, we've out since 1997, since unfortunately I've been around that long at EPRI, we have gone out and instrumented lines, doing DLR in the 90s before anybody else was thinking about it. And the interesting thing my team said to me is every one of our studies, we found a day when the wind was low enough that the actual real rating of the line was lower than the static rating, all right? So there will always be a day, maybe always be a day, but there's a high probability that there will be a day that the rating will be lower, will be its static rating. And you have to plan for that from a reliability point of view. But from an economic point of view, when you're there and there's a cheaper generator on the system and there's more capacity in that path, you can enable that generation to come in. And of course, the conductors in the system have thermal lag, if that makes sense. So if you decide, let's say the wind suddenly stops, well, you've still got 2 hours of knowing exactly what that conductor is going to do. I hope that made sense.
Do you have a quick follow-up before we go to Chair LeVar? You okay?
Decision that's fact-specific.
Yes.
In individual cases, it sounds like.
Everyone takes an individual study, and I should have said that on the power flow controllers, on the conductors, and on the DLR, it's a study that you look at specific paths and say, will this help us, and what's the cost benefit, and what's the risk benefit, and what's the uncertainty that comes with it as well.
Chair LeVar.
Thanks. I was going to follow up to your answer to Chair Phillips, although to some extent you've addressed it. But besides your comment on ensuring we look at full life of the technology, is there anything else that we should adjust in our traditional cost-benefit models to fairly evaluate these technologies against all other wires and technology solutions, so we're comparing everything on apples to apples? So
a little bit out of EPRI's bailiwick, all right, looking at the cost-benefit analysis. And side of it, incentive side of it. So I would say that, but the one thing that we need to think about more than anything else is how do we, these are unknowns, right? You're asking utilities that are very traditionally very, very conservative, all right, and have to be for us, to take on a new technology which comes with uncertainty. Uncertainty may just be because you've never used it before. It could be true uncertainty. You could be taking margin out of the system. If you think about static ratings, we've been operating the system with a static rating for 100 years. And really, we've had all this margin in the system, right? Okay. And now we're going to take that margin out of the system. And so now that increases risk by definition. It may not take us to a risk point that's important, that's close, but you've increased the risk. And so the question that I have is how do we, how do we motivate our utilities to take increased risk with these new technologies, all right, incrementally? And then how do we de-risk it for them that if it doesn't work out, that they don't have a stranded investment, or they don't have a, how do we motivate that to change the mindset and move people along the curve fast? I hope that helped.
We'll take two more. We're a little bit over time, and we have some remarks before we want to take a break. So Commissioner Allen, then Commissioner Duffley, and then we're going to go force members making some comments.
Thank you. Can you hear me? Great. So I'm struggling with a relatively high level kind of issue. I mean, it seems on one hand, there seems to be general acknowledgement or agreement that there's great opportunity for benefit on multiple fronts, economic reliability and environmental for these new technologies. And yet the pace seems to be at a very measured level. We seem to be on, you know, a really deliberate path of adoption. And that seems to contrast, at least I'm informed, by other nations like Australia and maybe Belgium in certain instances with, you know, a much more ambitious pace. And maybe the difference is essentially top-down direction. Maybe it's standards that have been set. My question to you is, from your perspective, what are the kind of key pressure points that, you know, policymakers and perhaps the industry itself should be moving forward to facilitate a faster pace of adoption, or is that warranted?
It's a fantastic question. I think if all the questions that I put up on the screen that the EPRI advisors or the utilities we're engaging are asking are answerable through testing, through studies, and I really believe, obviously I'm at EPRI, in a third-party unbiased approach, right, where it's an independent organization doing those things to increase the confidence. They're all answerable. The question, as you said, is just about pace and urgency. And the part that I'm not qualified or to answer is, how do we increase that pace? All right, okay, maybe that's this group here's job, but there is no, from what we see, there is no barrier that's stopped that says, no, it won't work. It's just, we need to answer these things. We need to increase the level of maturity, and we really need to answer those questions. And the question maybe for others is how to increase the urgency or the sense of urgency at which people do it, at which utilities do it.
Commissioner Duffley.
So something that I was surprised to learn when I was speaking with people preparing for this meeting, and I think I heard you state it in response to Commissioner Christie's question, is that when you're looking at GETS versus traditional build, initially I had thought, okay, it's a or situation. You can build GETS or you build a traditional generation. However, it seems many of the people that I have spoken with have said it's not an or situation, it's an and situation. And I just wanted to hear your perspective of what I have been hearing. And they say that it's a bridge potentially.
Yeah, so I think there may be two things that I would say. It definitely, so you're 100% correct. It's not an or, it is an and on a case-by-case basis. So not every case is going to be an or an and, but in many cases it could be an and basis, where you can get extra capacity by maybe building a new line and using advanced conductors. You know, just as an example, or using power flow controllers. But I think the shorter term objective could be bridge technologies, where to build the average line today takes between 8 and 14 years, if I'm remembering correctly. And so waiting that amount of time to increase the capacity of the network is just not just going to take too long. Does that make sense? And you know you're going to need that capacity in 20 years' time, but maybe in the next 5 years, you're only going to need a portion of that capacity. Can we get that portion of capacity using some of these technologies? So instead of thinking, well, in 30 years, I need a capacity of 50, all right, therefore I have to get 50, and all these technologies will only give me 20, so let's not do them. Rather say, well, for the next 5 years, we only need 20, so use it as a bridge technology. to get while you're building the other capacity. I still think we're going to need an enormous amount of other capacity. We're going to have to build a lot of new transmission lines. We're going to have to take existing transmission lines and upgrade them. And there are other options, not just reconductoring. There's HV to DC conversion. There's voltage upgrading. And also we have the ability today to build new lines that are higher capacity, that are lower in profile. So there are all these other options in the toolbox, which I wasn't asked to talk about today. We really should think about all of those options in the long term. I hope that kind of answered your question a little.
So thank you very much. And we have a few prepared thoughts, both reactions, and we'll start with Chair Scripps, then Commissioner Allen, Commissioner French, and then Chair Phillips. And then we'll probably take a break at that point. Yep. Chair Scripps.
Great, thank you, Dr. Phillips, for that presentation. And it's just fun to have both a Dr. Phillips and a Chair Phillips leading the discussion today. I just want to offer a few observations on some issues, including the scale of the opportunity that you touched on a bit, some of the inherent challenges involved, which you also touched on, and then why it's so important that we move forward on better integrating GETS into both system planning and operations. And I think it's possible to do both. Just a couple data points on the scale of the opportunity. MISO states adopted a position statement on enhanced transmission line ratings, one of the grid enhancing technologies that you talked about, in which it stated that OMS supports a well-functioning wholesale power market that delivers maximum value and reliability to customers in the MISO region, and believes that full utilization of the transmission system through transparent, enhanced transmission line rating techniques is critical to achieve this objective. Specifically, OMS noted that customers are harmed when transmission line ratings do not reflect the actual capabilities of the facilities based on changing ambient conditions. This can lead to higher energy prices and increased levels of congestion due to suboptimal power flows on the system. And to quantify the opportunity here, consider 3 examples from just the last 3 weeks. First, in a presentation at FERC's June 29th technical conference on increasing market and planning efficiency through improved software, Pablo Ruiz of New Grid calculated that even the limited utilization of another grid enhancing technology, topology optimization that you talked about, could relieve 98% of overloads and reduce 85% of congestion costs on analyzed constraints under normal conditions. But the results are even more dramatic in extreme weather events. A utility in SPP that implemented just 2 reconfigurations during Winter Storm Elliott released up to 854 megawatts from available plants upstream of the transmission constraint, adding about 14 gigawatt hours of electricity. Had just 2 other reconfigurations been done, it would have added another 600 megawatts of generation and 9 additional gigawatt hours to the system for a total of nearly 1,500 megawatts of capacity and 23 gigawatt hours of energy. And then last Thursday, in presenting a summary of the 2022 MISO State of the Market report, Dr. David Patton, the MISO Independent Market Monitor, stated that the use of just ambient adjusted ratings and emergency ratings could have saved MISO customers more than $540 million just in 2022 in avoided congestion costs, or nearly 15% of those total congestion costs. And then finally, and you mentioned the Grid Strategies report in your presentation, but they found that congestion costs increased 56% in 2022 to $20.8 billion. But that the utilization of GETs like dynamic line ratings, topology optimization, and advanced power flow control could relieve at least 40% of congestion in many cases. And to see just how quickly costs have grown recently, the total transmission costs across the US in 2019 was $3.7 billion. In 2022, that was just MISO's share. As Richard Doying, one of the authors of the report, noted, grid enhancing technologies can be deployed to reduce congestion in the near term and supplement future traditional infrastructure development, which can take a decade or longer to move from planning to operations. So given that enormous opportunity, I think we need to ask why GETs aren't being implemented. And you highlighted a number of the technical reasons, but at least part of the reason is also that at least today, there's little incentive for transmission owners to use them. Again, Dr. Patton from Potomac Economics noted in comments following FERC's September 2019 technical conference on best practices and commission policy alternatives regarding transmission line ratings, said, one of the reasons transmission owners do not adjust their ratings is that they generally lack incentives to do so. When existing transmission investment is recovered through embedded cost transmission rates, there is little direct economic benefit for adjusting the ratings upward to account for ambient technologies. Yet, as you noted, some utilities actually have moved forward to implement GETS, recognizing that we will exhaust the capital customers are willing to provide long before we run out of places to spend money in the transmission system. And as regulators at both the state and federal level, that, I think, needs to be our focus, particularly at a time when I believe significant investment is needed in backbone transmission infrastructure to maintain reliability in the face of an aging grid, increasing extreme weather, and an evolution in our generation assets. If we don't squeeze every drop out of the existing system, it's going to be a tough sell as we consider the costs involved in transmission expansion. And I believe that grid enhancing technologies can help us do that, to maximize the value from the infrastructure that we have today. And that's why I'm so pleased that we're having this discussion.
Thank you. Commissioner Allen, a little closer to the mic.
Yeah, thanks. So I was, in my comments, just going to drill down a little bit on kind of the benefits. When I, in preparing for our meetings, I just was struck by the many kind of categories of benefits that are out there that seem to be well recognized and seem to be kind of studied and validated by pretty credible institutions. But before I kind of run through the list, I just wanted to acknowledge that a point that the results are also seem to be highly variable. That is, different regions have just very different opportunities as it relates to these. So I don't think it's easy to kind of make sweeping judgments about the widespread benefits. I know in New England, with low congestion costs as an example, the operational or economic benefits of dynamic line ratings or some of these other technologies aren't quite as apparent as others. But let me just kind of go through the list, because I won't cite to the studies. I do have cites to studies, but that seemed over the top. So at a very high level, it's just improvements to the capacity of the system. I've seen numbers north of 40% improvement in the capacity of the system, of the bulk transmission system. These are improvements that can be made short-term through operational improvements, but they also can provide a bridge to essentially lasting constraints, or constraints that can't be quickly addressed through the build out of the transmission system, which can take years of time. It can lower the interconnection costs, can shorten study times, and reducing the cost of interconnection generally, but also reducing the timeframes for interconnection, which of course is critical to bringing on new resources. So if we look at what's in the queue today, the queues today across the U.S., it's wind, solar, and storage. Economic benefits I mentioned, reduction in relatively short term, reliability, mitigating outages, and improving the visibility and flexibility of the system to essentially adapt to challenges. I won't go any further than that, but just say that the benefit, the paybacks, when you look at even just a narrow set of categories, seem to be fairly robust as we think about kind of changing and making reforms in our planning structure going forward. As we think more holistically and long terms, it seems like that would have a magnifying impact on the opportunities that are in front of us. I'll stop there.
Thank you, Commissioner. Commissioner French.
Thank you. I know we're running a bit behind, so I'll try to be as brief as possible. I think I'll just say, as we entered into this conversation, and as GETS have started to come on the scene, my initial understanding of GETS, it was initially just as a low-cost opportunity to bring more generation online and get it through our queues. And I say just, I mean, that's a big benefit, but I think as I've learned more about these specific technologies and their use cases and how even our traditional utilities in my region are starting to embrace them, I am now seeing that some grid enhancing technologies offer a very material opportunity to serve customers more efficiently today. These technologies aren't just able to bring more generation online. In fact, perhaps the most compelling case to me for these technologies is that right now they can reduce grid congestion, allowing our markets to consistently access lower cost power and to respond to real-time reliability issues. And that's particularly important when we're dealing with extreme weather events. In my view, the biggest opportunities right now are in the area of operational software, particularly topology optimization software. I'm glad you got around to that, Dr. Phillips, that could assess grid conditions and suggest reconfigurations to respond. Right now, we treat the grid as a completely fixed asset. But in fact, it already has the capability to have reconfigurations. This makes it a very underutilized asset. We're doing this, as Dr. Phillips said, because one, our operators are rightfully conservative. They don't want to make a mistake. But we're also operating this way because assessing all the possible reconfigurations of the grid involves very complex number crunching of giant data sets. It was not possible to do this sort of analysis in the past, but now we are beginning to develop new tools, software, computing power that can put this at our fingertips and unlock that capability. Assessing and reconfiguring the grid will become more commonplace in the future, in my view, even as we add more backbone transmission. And it's my hope that software solutions will become a foundational investment that helps us make fuller use of more grid enhancing technologies. For example, grid reconfigurations can be even more flexible if advanced power flow controls are strategically added to the grid in key locations. And eventually, I'm envisioning a day where software could assess weather data, line ratings, and resource availability to identify next day congestion and solve or mitigate by reconfiguring, saving customers money. And I think I also view that very much as acting as a bridge, because it's unquestionable that we will need to build more transmission in the future, but the question is what you do in the next 8 to 14 years. And these types of solutions are available to us right now to unlock the grid, to save customers money while we do the planning and develop long-term solutions. Thank you.
Chair Phillips.
Dr. Reb, I will actually let that be the final word. I know we're running short on time, so I'll yield the rest of my time and I'll say some more stuff later.
Okay. And I'll just ask the rest of the task force, who I'm sure maybe wanted to respond, to just roll your thoughts into the conversation after the break, because we're about 7 minutes behind. So we'll take a 10-minute break. I asked the audience to allow for a clear path for the task force members to the beverages and the facilities if they need them, because 10 minutes never really works, but we'll be back at 3:47. Yes. And thank you, Dr. Phillips, again. So just, what's that? Oh, there we go. So for this next part, we've got 5 different questions that we're going to discuss. We have a couple of state commissioners and a FERC commissioner for each question. Since the audience hasn't seen the questions, I'm going to read each one as we go along, and we have a slightly different amount of time. Hopefully, once the opening remarks are done, we'll have some time for cross discussion, but we only have about 12 to 14 minutes per question. So for the focus here, so as we were talking last time about the types of guests, potential benefits, the risks, the way the utility industry is viewing them. So in this session, we're really thinking about how we improve integrating guests into our planning processes, and what, if any, types of policy changes we might need at state and federal level. So the first question that we plan on discussing is, do the existing transmission and distribution planning processes sufficiently or at all account for the potential risks such as reliability and resilience, operational challenges, and benefits of GETS? And we will start with FERC Commissioner Christie, and then we'll have Chair LeVar and then Chair Scripps. Commissioner Christie.
Well, it's sort of a categorical question, and it's the challenge, it seems to me, with GETS is a very sweeping term that covers a lot of things. DLR is a thing. We have an NOI on DLR right now. Ambient adjusted ratings is a thing. We did an order on that. There's a lot of other GETS. When you talk about what regulatory changes are needed, it seems like it alluded to the question I asked Dr. Phillips, not Chair Phillips, Dr. Phillips. Trying to a priori say, do this or don't do this, is really challenging when sometimes this is not appropriate given a factual situation. That's the challenge. And it seems to me, from a regulatory standpoint, we need to really listen to the engineers on this, who are deciding on an individual basis what works where. So we want to get it right, obviously. There's tremendous benefit if you get it right. There's not benefit if you don't. You can have reliability, cost issues. So potential benefit from GETS categorically, having a categorical use it all the time everywhere, it doesn't seem that's appropriate either. So it's there's a lot of nuance that's necessary, seems to me, about, and at the end of the day, it seems like it is fact specific, and it seems like you want to make the engineers defer to the engineers, but make sure the engineers use their expertise and tell them, we want you doing this, we want you looking at these, we want you deploying these whenever and wherever they work. And I know that's sort of those are general comments, but again, it's a sweeping term. And so categorically to say, you shall do it everywhere all the time, it seems would be a very broad brush.
Chair LeVar.
Thank you. Dr. Robb, in response to your question, my short answer is yes, if we model it a thorough way. My slightly longer answer is that in the areas of the West that are not currently participating in an RTO or an ISO, both the transmission and the distribution planning processes rely heavily on individual utility integrated resource plans. With the right modeling, these holistic plans can be robust regulatory forums to evaluate cost, benefits, risks, and challenges of grid enhancing technologies. When done properly, an IRP process should model all wires and technology options to arrive at least cost, least risk results. And there shouldn't be a need to transform these regulatory processes as new technologies become available. My personal views on these issues are guided by these regulatory processes across the West and by the legal and regulatory framework in my own state. Those frameworks lead me to two convictions. First, that effective regulation is technology neutral. And second, that if government is going to incent specific technologies, it should happen through tax policy, not through economic regulation. Integrated resource planning is holistic. Every state in the West has different processes and regulatory structures, but all share some common characteristics, including robust modeling requirements and open stakeholder processes. To me, this is an appropriate technology, as long as the stakeholders and regulators ensure the modeling is fulsome and flexible enough to handle new technologies. If there's a need for regulatory incentives, it should be incentives to ensure the modeling is sufficient to accomplish those goals. Modeling like economic regulation should be technology neutral. That's very different from regulatory economic incentives directed at specific technologies or outcomes. When government chooses to incent specific technologies or outcomes, those incentives should come through tax policy, because when those incentives occur instead through economic regulation, they are both less transparent to the public and are among the most regressive government incentives possible, impacting the lowest income customers most severely. One example of a reason economic regulation should remain technology neutral is the risk of wildfires. If there's any issue in the Western United States more pressing than transmission capacity, it's wildfire mitigation. And it's a positive thing for regulators to receive briefings on technologies that can increase transmission capacity without increasing the risks of wildfires. But when the time comes to make that argument to a jury that's evaluating the liability for a specific wildfire, none of us on this task force will be the ones making that case. That's one important reason, in my view, to avoid outcome-based regulation. Regulators shouldn't have our thumbs on the scale to pick winners and losers, or to block or get in the way of consideration of any new technology. Regulators are obligated to ensure that whatever processes we're using entails robustness of any new technology, and this should be our goal with all of our regulatory decisions impacting new technologies and grid-enhancing technologies. Thank you.
Chair Scripps.
One of my favorite parts about this task force is that you often get to see the diversity of the different regions on display. And so my view is almost directly the opposite of Chair LeVar's, not that he said, but because we come from different regions. In MISO, the existing planning processes do not account for GETS at all. And MISO planners have been fairly clear that they do not believe it is appropriate to account for system flexibility in the planning process. Now, it's important to distinguish between operations and planning that we have a number of times that RTOs are in many cases able to institute reconfigurations when there is a pressing reliability issue in real time, but are more hesitant to act in a proactive way that is only focused on economic benefits, to sort of steal from my friend from Kansas. And in MISO, the long-range transmission planning process really barely accounts for seasonally adjusted line ratings at all. In my view, that this is not sufficient. Reliability models that examine stressful grid conditions in various seasons should utilize reasonable weather data, and I think that you can do that within the planning process in addition to operationally, particularly when we start thinking about the combination of GETS to ensure reliability of the system. As Dr. Phillips talked about, that one day when the static rating is the same as the dynamic or ambient adjusted rating, maybe that's an opportunity to use topology optimization, for example, to reconfigure the system to address the real-time transmission constraints or issues on the day when those things ultimately converge. And then finally, just a word on distribution planning. I know that we're transmission focused, but it was in the question. Distribution planning varies considerably across the utilities and across the 14 states in the MARC footprint. In Michigan, we've adopted distribution planning to provide greater context for specific investments that are proposed in utility rate cases. But unlike our IRPs, these are not contested cases, and distribution plans do not require state commission approval. Other states do it differently, but inherent in the review of distribution plans is the consideration of alternatives, and my view, again, is that this should be the same with the transmission planning. But unlike in transmission planning, where you can consider alternate transmission lines or even non-wires alternatives, there's no clear way today to consider GETS as alternatives, and I think this is an area where more work is needed.
Great, so we have a few minutes to hear from others, either reactions to what you just heard from your fellow task force members or some of your own thoughts on whether you feel like your regions are adequately thinking about the benefits, potential risks, challenges of GETS. Similar, different? Yep, Commissioner Allen.
So I'll just say from my region, you know, I think it's just very spotty. Our utilities and our RTO, I think, are in a very measured and deliberate phase of doing pilots and working with the utilities, but it's not in the planning. As far as I can tell, it's not a regular part of the planning framework, at least within my region.
Anyone else want to jump in? Or we move on? Yes? Both of them? Just him. Okay. President Fiordaliso?
Yes, thank you very much. I see you have my card there. I couldn't put it up. But the point is, I agree that we have to be prudent in our approach as far as GETS is concerned. But I also believe that the amount of time that we have is not sufficient. If what we understand from scientists and so on, the acceleration of climate change has intensified, and our time frame has been minimized. I'm not saying throw spaghetti up against the wall and see what sticks. What I'm saying is we have to be prudent. We have to always keep the ratepayer in mind. However, we must not be complacent in our approach, and we must not waste time as we move forward to implement various different. Thank you.
Thank you. Anybody else before we're going to move to the next question? Great. So now we're talking about, the second question is, how can the consideration of GETS be better integrated into utility, state, and regional planning efforts such that GETS are considered concurrently with traditional transmission investments? And we'll start with Commissioner Houck, and then Commissioner Allen, Commissioner French, and then Commissioner Metz.
Oh, okay, am I starting? Or is Commissioner, okay, all right.
Unless you have a different order.
I had a different order, but I'm fine with with going ahead. So again, this morning we heard, or this, I guess, afternoon, we've heard from Dr. Phillips and others on the task force about the potential benefits that GETS can provide, and as Commissioner Christie noted, in the right circumstances. In short, GETS can enable more efficient use of the existing grid, thereby increasing reliability and resilience while simultaneously capturing significant cost savings for end-use customers as compared to capital-intensive transmission projects where appropriate. GETS can also help facilitate the clean energy transition by avoiding the curtailment of renewable generation and accelerating the integration of renewable resources on the transmission system during this critical period before new transmission projects can be completed. There are, however, certain fundamental challenges with the regulatory framework that impede integration of GETS. For example, as explained in the 2019 white paper prepared by Grid Strategies and the Brattle Group, the performance of utilities is measured in terms of meeting minimum reliability thresholds and not maximizing or even increasing operational efficiency. Utilities are also not necessarily directly economically impacted by the inefficient use of transmission infrastructure, where they're able to pass on resulting congestion costs to other market participants, such as generators and load, who do not have the physical capability to reduce congestion on the system. And even more importantly, utilities are financially motivated to build more capital-intensive transmission projects to grow their rate base, which they earn a return on. By contrast, GETS may defer or negate the need for such capital projects, thereby reducing utility revenues. So the question of utility revenues and incentives is something that we'll definitely have to address in looking at incorporating GETS into our grid planning. So the question is, how do we ensure fuller consideration and ultimately broader deployment where appropriate of these technologies? And I'm going to discuss 3 potential reforms that can help us get there. And first is the importance of transparency, subject to requirements governing the disclosure of critical or non-disclosure of critical energy infrastructure information. The Commission should direct grid operators to provide stakeholders with their power flow studies showing constraints and overloads on the system and the underlying inputs, assumptions, and criteria used to develop these studies. For example, the Commission could require grid operators to provide sufficient information to enable stakeholders to identify where implementing dynamic line ratings may help address congestion, thus informing whether wholesale rates are just and reasonable without the use of DLRs. Further, the Commission could require grid operators to provide this information early in the transmission planning and interconnection process so stakeholders are able to consider and, where appropriate, propose alternative solutions involving the implementation of GETS. Second, I want to talk about transmission planning and the transmission planning and interconnection processes. And the Commission could require grid operators to analyze GETS in a way that would provide more efficient and cost-effective solutions than transmission upgrades. And so to do this, the Commission could require grid operators to consider DLRs and advanced power flow control devices. And we would also urge that you go further by requiring grid operators to consider additional GETS such as storage. We also would propose that grid operators consider GETS for feasibility, cost, and time savings, not just if requested by an interconnection customer, but just as part of the general planning process. And that it be triggered, again, not by a request from an interconnection customer, but integrated into the overall process. We also would support the recommendation by the Watts Coalition that grid operators be required to explain their reasons of GETS in their grid planning interconnection projects, and that the explanation should contain sufficient technical information to enable customers to validate the grid operator's determination. And we similarly encourage the Commission to expand on reporting requirements that direct grid operators not just explain their reasons for adopting certain GETS, but by requiring such explanations for a broader category of GETS, and most importantly, by requiring grid operators to provide adequate documentation, including, for example, again, power flow study results and asset condition and performance data for projects that are proposed that have an initial cost estimate of more than $10 million. And third, California also, as in prior meetings, urges the Commission to establish an independent transmission monitor that would be charged with objectively assessing whether a selected transmission project is the most efficient and cost-effective solution as compared to other alternatives, including GETS. And ITM's independent and expert analysis of such alternatives will be indispensable, both by providing needed transparency and ensuring full consideration of GETS in transmission planning processes. Apart from the Commission-led transmission and interconnection policy reforms that I've mentioned, it's also possible that regional initiatives subject to the Commission's approval may result in increased efficiency and utilization of transmission lines from the broader deployment of GETS. For example, the Commission should explore whether regional initiatives to reform interconnection processes could unlock additional capacity from implementation of GETS and thereby improve interconnection queue management. The California Independent System Operator has recently initiated a stakeholder process, the Interconnection Process Enhancement, or IPE initiative, that could fundamentally change how new resources are added to the grid in California. The CPUC is participating with other stakeholders in the development of an improved interconnection process that is more closely linked with California's resource and transmission planning efforts, and that will potentially provide for increased incorporation of GETS in the ISO's transmission and interconnection studies. And we anticipate the ISO will be filing its proposal for a new interconnection process with the Commission early next year. So with that, and again, understanding that we need to make sure these technologies are implemented in the correct circumstances, and also look at areas that we can address incentives and compensation. I will conclude my comments.
Thank you. Commissioner Allen.
Sure, thank you. In order to be efficient, I think I'll just sort of run through what is a wish list. It's a wish list, essentially from my perception of my state and the region. But I think it covers, some important topics. First off, I just want to, highlight that I actually think that considering the planning frame and recognizing that the planning frame doesn't need to just focus on reliability, that there are other categories of benefits that should be included here, consistent with the FERC NOPR and the discussions we've had earlier, I think is valuable. So expanding the scope of benefits, but also expanding the scope of technologies under consideration in a planning and operations frame. I think motivation of the utilities is relevant here. There are some interesting proposals for essentially instilling greater motivation by the utilities and trying to move these technologies forward at pace. One is proposed by the Watt Coalition and Rob Gremlich and others, and I think those are interesting proposals that should be explored. I do think that, getting back to Darcy's point about transparency, I think there are opportunities for recognizing that what we have is really a host of different pilots that are going on kind of across the country with different technologies, and I'd like to see more transparency and sharing of information across the nation as we make progress to consider the value and benefits of these technologies. There's planning and there's planning. We have bottom-up planning in my region, and we have top-down planning. I can see transmission planning, long-range transmission planning being incorporated in our own local transmission planning process. We consider the transmission technologies, we consider the non-transmission technologies, and I think that grid enhancing technologies could fit, well into the framework that we have for kind of more of a bottom-up. I do think on the top-down planning that goes on more at the regional level, I think there could be scenarios that are actually built that are recognized. The performance of a system that has, a rich body of grid enhancing technologies incorporated in some scenarios to help highlight, the urgencies and to help ensure that there's good coordination, not only with the planning side of our RTOs or our control and planning bodies, but also the operations side of those planning bodies. I think states have an obligation, an opportunity to vet individual projects, and just through the examination of those projects and in the permitting and siting process can help to ensure that these technologies are considered along the way. I think there's a state role not only on an individual by individual state, but also in motivating collective action in multi-state RTO regions. Commissioner Howard highlighted the advantage of the single state RTOs, but I think there's, I think in the multi-state RTOs, there is some progress being made to help to motivate action through effective use of our regional state committees. I'd like to see a role for developers in the planning process. I think they can play a constructive role in providing a voice. I'd like to see that role played early in collaboration with the utilities, but I think creating a space for them in the planning process is constructive. And finally, I'll just say that part of the problem with some of these technologies, like the dynamic line ratings, isn't so much the congestion within the region. Congestion within the New England region is actually not a huge issue. I think the studies kind of help show that by comparison, it's not a big, it's really over time as we look forward that it might present a larger issue. And it's also kind of importantly in between the regions. So it's New England relative to the neighboring regions. There are seams and there are areas of congestion, and they can be relieved through coordination. And it's I think the pushback on that is it's just not easy to make that happen. And I think that requires some regulatory interventions to help ensure better and easier collaboration between regions. Thank you.
Commissioner French.
Thanks. So the question here is, how can grid enhancing technologies be better integrated into transmission planning processes? But there's been a common thread through several folks' comments that we sort of have this silo of planning and operations, and a difficulty for people to get their heads around how those two interact. And I will say that I have come to the belief, and maybe I'm cheating on the question here, but I've come to the belief that initially, at least, I think the reforms are going to have to be to operations, to create an ecosystem that can accept and use the new technologies and data. So for example, I spoke earlier about topology optimization software that could identify grid reconfigurations for either economic or reliability reasons. Today, that's mostly used by a few proactive utilities that have to individually contact their RTO or system operator to suggest on a case-by-case basis a reconfiguration. It would make much more sense for that technology to be deployed in the central control rooms of system operators to holistically evaluate the grid. But that will require training, and it will probably require a nudge from the Federal Energy Regulatory Commission. I think what I would endorse is an approach like what this body did with Order 881 of mandating new operating practices for transmission service providers. A next step could be to require certain capabilities like software for topology optimization and mandate processes to merge data and capabilities with day-ahead and real-time operations. Essentially, require the ecosystem to be made ready for grid-enhancing technologies and get control room employees trained up so they can use and embrace the technologies. I think once you are able to implement these technologies into day-to-day operations, we will then be at the stage where their capabilities, their risks will be more fully fleshed out, and that may be the time where we're all more comfortable inserting it into the planning process.
Commissioner Clements and then Commissioner Christie.
Thank you. Oh, it's on.
That's good.
Thanks. You know, the short answer to how do you better integrate it is for the commission to require utilities to consider whether or not to use them, and then to align the financial incentives so that they're encouraged when they're considering them to use them if they make sense, to Commissioner Christie's point, and to the extent possible in a technology neutral way, to Chair LaVar's point. You know, what does it really mean to integrate grid enhancing technologies into planning? It is this provision of more options, more choices, both on the existing system to squeeze more juice out of the existing system, because that is near term, that is cheaper, that is easier, even though we saw, you know, a case study of potential risks which exist for any type of technology investment. And then also think about how that sits next to the need for new transmission investment. And reflecting on a couple of the things that have been said so far, I think there are two myths that still need to be dispelled about the use of grid enhancing technologies. And the first one is this scary, new, untested, not technologically proven. I think I think Dr. Phillips gave a very informative presentation, and the only place I would disagree with what he said was that some of those risks the existence of those risks shouldn't stop us from start requiring consideration of the deployment. And certainly the many cases we've heard so far about entities that have used dynamic line ratings to the benefit of customers have found ways to manage those. We've mentioned, Chair Scripps mentioned a lot of them. There are a couple more that haven't been mentioned. You know, the use by PJM and ComEd together, who chose a modular advanced power flow controller as a network upgrade. Cost savings, $50 million. That's one network upgrade, right? NISO has did a modular power flow control for a network upgrade choice, and I think that savings was $10 million. In the UK, to your point, Commissioner, National Grid unlocked 1.5 gigawatts of capacity for customers on the transmission grid and saved roughly the equivalent of $400 million. One use case, right? They're finding way through these risks. We've been using these technologies for some time, and I do think it's important to consider them. If they don't work, don't use them for that purpose. Do something else, but they are a part of a toolbox of solutions that we're able to take advantage of. And then the second issue is this planning operations timeframe issue that gets people stuck up and, or, kind of spun up. And I don't really understand what it means, to be honest, as a starting point, because you have to plan to use these things in the operational timeframe in the first place. And some of these grid enhancing technologies are effective tools in the planning horizon, whether it's in the interconnection process that I just discussed, or in the planning process. And then it creates a positive feedback loop. When you start to use topology optimization, when you start to bring back the data from dynamic line ratings on some subset of your system, you start to learn a whole lot more about your system. And that helps to inform cost-effective planning. So I think both are important. We're seeing how they're being used in these examples in the planning time frame. And so there shouldn't be a resistance to the idea. The opportunity is so big. These numbers are major league numbers. They're not small, chipping away at the margins. And the time frame to use them is short enough that if we can figure out a way as regulators to require this stuff in a growth mindset of regulation, we have a couple times to screw up, and customers are still going to be the winners, right? If it's not providing the reliability or the economic value in the instance it's established, move it or change it or don't do it again. I think there's still learning to do, but I think we're past the point that we should just continue to kind of hope organically that it happens without taking more proactive action as regulators on behalf of customers. Thanks.
So we're a bit over time, but let's take Commissioner Christie. The next question in some way, some of you have touched on, and we'll continue this conversation, but let's take Commissioner Christie and then move to the next question.
I want to respond to Commissioner French's statement, which I agree with, that you referenced Order 881, which was the AAR, and I think that's a good approach. And I think you're probably right. Probably the operational comes before the planning, because if they are deployed operationally and work, then boom, you've got proof. But I wanted to ask whether Karen or Matt knows, we have an open proceeding on DLR right now, and just what the status is on that, because anybody? It's an NOI, which in our lingo means not quite a NOPR, which means a proposed regulation. But where are we on? Is all the comment in? I mean, where does that NOI on the DLR stand? Still reviewing the comment?
Hello? We are still reviewing comments. It's still open matter.
Okay. Well, I would hope we move on that DLR, because I mean, we all know DLR has tremendous potential. Again, it's getting it right and getting it out there where and when it works, because it does have, by all reports, tremendous potential if in certain times at certain places. And Riley mentioned New England. You all built so much transmission, you don't have a lot of congestion costs, so you're probably not going to see the same immediate cost benefit, because you sort of eliminated, according to Gordon, congestion costs with all your transmission. But it clearly has a tremendous amount of potential, and so we have that open proceeding. Hopefully, we'll move on it.
Moving on to the next question, which is, what role can both state and federal regulators play in securing that beneficial integration of GETS into the planning processes? And again, some of the speakers touched on this, but we can go more into depth here. We'll start with Chair Phillips and then go to Commissioner Howard and then Commissioner Duffley.
Thank you. I have a question for everybody. All right, raise your hand if you remember, or if you had in your car a big book of maps to figure out where you go. A big book of maps. Like, I mean, mine was huge. You had like 2 people to hold it almost. Raise your hand. Like, I'm serious. Do people have? There are lots that still got it, right? Commissioner Christie just made my point. He has a smartphone that has Google Maps, and that's what he uses. He said he didn't say he used it. But here's the point. I view GETS the same way that I used to view GPS navigation in my car. I was devoted to my maps. And I remember when it first came out, it was that little system you had to have on the dashboard. And I was like, man, that thing is distracting, right? I mean, I got my map in the seat beside me. I know exactly where I'm going. But when you think about how to use GPS, you don't use it like a map. You don't set it one time and forget about it. When you're in DC, you're riding along, you might encounter construction, right? And what does your GPS do? It renavigates. It gives you an alternative route to get to where you're going faster or even more efficiently than you originally planned. Same thing, if there is construction and that construction clears and you still have these phantom buildups on the road, your GPS can give you a new route to go around. You use GPS at every system, at every turn throughout your transportation journey. I think that's exactly how we should use GETS. We should use it in the interconnection queue phase. We should use it during construction. If I say use, I mean consider. We should consider it during the construction phase. We should consider it after construction and during implementation. Because if you take a step back, and the question on the table is, what is the role of regulators? If you take a step back, we're economic regulators. It's been said, that's true. But you look at the grid strategy study, they say $12 billion of congestion in 2022 alone. That's just for RTOs. If you look at the entire country, it's over $20 billion of congestion. If we can use GETS to bring that number significantly down, I think it's incumbent upon regulators to do just that. Now, if we don't, under the regulatory compact, if we don't incentivize utilities to use GETS and other tools to bring that cost down, we're choosing a technology that they can make money off of. I think it was the great philosopher, Sean Carter, or Jay-Z, that once said, if it doesn't make dollars, it doesn't make sense. Same thing here. As regulators, we need to make it make sense to reap the benefits to our consumers, to our businesses, and to do our job. So my question to my colleagues would be this: what have you seen in your state? What ideas do you have that we can share on how to incentivize our utilities to do what we and what the people we regulate and the constituents that we have, what they want to do? Thank you.
Commissioner Howard.
Thank you. As I stated earlier, we have made GETS integration a component of our planning process, and planning process not only generically, but specifically as different programs come to about, whether they're PPTN or utility-based proposals. You know, one of the things since my brief appointment to this task force is I've had a parade of technology providers approach me about their new best thing, and which got to me to this point of how do we develop standards? We in New York rely on an advanced technology working group to help ascertain the best aspects of the various new technologies as they come along. And as Dr. Phillips pointed out, and Commissioner Clements pointed out, some of these are not brand new stuff. This has been around a long time. So the issue becomes not only, and as also Commissioner Christie pointed out, this is also best done on a case by case. Not every technology fits every application. For instance, what may be appropriate for an offshore transmission project or a large, many miles undergrounding project is far different than what you might want for a overhead project that may be a half-century old. So to that end, I do believe, and this is maybe more difficult for you, Mr. Chairman, is that the role of the federal government to provide clear guidance to RTO operators and states as to technology maturity and effectiveness, and in what circumstances it's most appropriate. And to Commissioner Clement's point, we are certainly in New York and the New York ISO area poised to spend tens of billions of dollars on new transmission now. This is not something that's going to happen 20 years from now. The build out will take 20 years, but we're doing it now. So what is the most appropriate technologies that can be integrated into the system? I know it's difficult being the first cow over the fence, but there is a role, I believe, for the federal government, particularly in multi-state applications, to give guidance and maybe even hard regulation on what is appropriate and what we should expect of individual technologies.
Thank you, Commissioner Duffley.
So I'll first talk about what state commissions can do, and then maybe move to a suggestion for FERC as well. State commissions definitely have a role in the implementation of GETS, and I agree with Chair Scripps and Commissioner Clements that we need to squeeze every bit of value out of our existing system for the benefit of our ratepayers. One thing state commissions can do is to evaluate their existing rules to ensure that they're creating conditions for GETS to be considered where appropriate. In commission proceedings such as IRPs, multi-year rate cases, and transmission siting proceedings, commissions can encourage the consideration of GETS and thereafter determine to what extent GETS can benefit the system and ratepayers, again, where appropriate. But given the range of technologies and the situational nature of their applicability, it is more appropriate for regulators to create these conditions in which GETS can be evaluated versus prescriptive rules. I think we can all agree that these technologies are not a one-size-fits-all. I've heard it several times today, and should not be deployed that way. Some think that these technologies are used only for operations versus thinking about GETS in transmission planning. We heard about the conservative operations workers. How can we determine as a state regulator and a federal regulator whether that's a valid assumption or not? I think the way that state regulators can find out is to encourage pilot projects that may assist everyone to see what the value or what value the consideration of certain GETS could have in the planning space, not just the operations space. With the implementation of pilot projects, there could be more comfort in assessing GETS in the planning stage, so it would be more of a two-step process. And I agree with Commissioner Allen about his comments about transparency, that the lessons and results of these pilot projects can be shared with others. However, to obtain that comfort level by the operators of the systems, the ones that are the providers of last resort, independent pilots may be helpful. They may not feel the comfort level just obtaining the information that it worked for someone else. One point for the FERC to consider is how will cost allocation work when GETS are used as a bridge or deferral of traditional transmission build to allow more interconnection while the traditional line works through the process. What happens in cost allocation, especially in RTO regions, when the traditional line is built, completed 2 years later, 5 years later? I think that for those RTO states, that might be an important consideration. The last point is we should all encourage NARUC to get involved in this discussion so that any deployment enhances or at least maintains reliability.
So unfortunately, we don't have time for our usual witty back and forth, which would be great, but we have 2 more questions and it's after 4:30, so I'm going to just soldier on. The next question is, what are the barriers to GETS adoption? For example, cost recovery, financial incentives and disincentives, and how can they be addressed, including through changes and innovations in regulation? We're going to start with Chair Gillette, if we can beam her in from Connecticut, and then Chair Pridemore, and then Commissioner Clemency.
Hi, thank you so much for the opportunity to comment on this question. One of the benefits of going toward the end is I've had the opportunity to listen to everyone. Unfortunately, I'm not going to be able to remember who I'm agreeing with or disagreeing with at this point, so I'll leave you to figure that out for yourselves. But I think to respond to this question, I think we should really start by acknowledging that while it's a laudable goal to discuss being technology neutral or to discuss the need to de-risk alternatives like GETS, I think that these thoughts face kind of an inherent internal conflict, because if we're choosing not to address the barriers to adoption, whether those barriers are real or imagined or perceived, I think you're not being neutral. In fact, but instead, if you're accepting the status quo, which is to my mind heavily weighted toward increasing capital expenditures by incumbents, I think you are in fact making a choice and you're not neutral. So I'd start there and say, I think that there are barriers to deployment, and the fact that we only have GETS in certain areas of the country at this point, I think speaks for itself. So if we're talking about how we address some of those barriers and whether there needs to be an incentive, I think we've heard some today, and we could continue to disagree about like how to incentivize deployment, even if we agree that we need to. And we could disagree about whether that occurs through economic regulation or otherwise. But one thing that I think is immediately within the purview of both state and federal regulators, which I think we could invoke here, is a reliance on a traditional prudency lens. So by that, I mean there are states across the country at this point, including Connecticut, that are establishing processes at the distribution level, which I think can be analogized and mirrored here, where we're focusing on removing barriers to the deployment of non-wire solutions. So in Connecticut, for example, we've established a multi-tiered process where there is essentially a rebuttable presumption, and you're looking at tiers based on project expenditures, where it's understood that the distribution company has to participate in this process in good faith to consider non-wires alternatives as a condition of demonstrating to us down the line that if they do pick a traditional solution, that that traditional solution is prudent and reasonable. And one of those conditions is that they had a good faith participation in that process. So also, I think to be successful, you need to bridge the information gaps in that process. I think Commissioner Halp did a really good job of explaining ways in which you could do that. And so I'll defer to her comments. But then just to address the flip side of that coin, not all about disincentives. I think that you can pair this with some other tools in our toolbox. But getting past that, those strong disincentives. So pairing it with things like a shared savings approach, which I think there's a relatively well-developed straw proposal that has been put out into the public arena by the Watts Coalition. So I would refer and really commend people to that proposal that looks at a shared savings model to incentivize deployment. I think there's some really interesting thresholds, like looking at congestion costs that could be, kind of manipulated to better tailor to GETS. So kind of in conclusion, I'd say the third part of the question that was posed here, as I understood it, is how do we ensure that ratepayers are the ultimate beneficiaries of GETS? And I think our ratepayers need us as regulators, whether state or federal level, to define the rules of the road and to insist on a fuller accounting of how an incumbent lands on a capital intensive solution, whether we're discussing transmission or distribution. So I think to do this, we can pair a healthy disincentive with potential incentives, but I do think we need to go beyond the simple instructions that GETS should be considered. And I'd say, like, as an engineer and a lawyer myself, I can appreciate the desire to defer to utility engineers about when and where gets are appropriate. But the reality of the situation is those decisions are not made in a vacuum within the utility, within their system planning departments. So I think we should turn, collectively to an old adage here, like trust but verify. And I'd add to that an addendum that we should all trust but verify, but also encourage and enforce if necessary. So I'll wrap there, and thanks for the time.
Thank you. Commissioner Pridemore.
Thank you for the opportunity to address this question. And like my colleague, Commissioner Duffley, I agree that we should get NARUC involved in this, as it's so very critical to what they do. And it's a wonderful suggestion. Some barriers to GETS adoption exist, but let's spend some time on how barriers have been overcome. Vertically integrated utility states, such as in the West and the Southeast, are uniquely positioned to and do evaluate and invest in GETS when they make strategic and financial sense for consumers and the grid. Like some of my colleagues have stated, though, as a software and hardware grid add-on, GETS do not replace the need for new transmission over time. GETS should be evaluated by state regulators through comprehensive integrated resource planning and transmission distribution planning dockets. In Georgia, that planning process has approved and implemented dynamic line ratings, which have been in the field for many years. Recently, in the 2022 Georgia Power Integrated Resource Plan, the Georgia Public Service Commission evaluated and approved Georgia Power to implement 2 STATCOM projects, static synchronous compensators. These STATCOMs manage voltage controls where there is increased demand. The decision to incorporate these STATCOMs will assist Georgia through fleet transition and address grid constraints. We know more new transmission is needed at and near these deployments, but these STATCOMs will close the gap between newly increased demand for electricity and the time that it takes to build new transmission lines. With the $13 billion that GETS is eligible for in the IIJA, RTOs and utilities are looking to apply. But even with the incredible amount of federal money available, GETS adoption should fit within long-term strategic planning. Because technology standards and languages are ever evolving, states and our federal counterparts should shy away from mandates on specific systems and specific types of GETS. Technology evolution will continue to provide efficient, visible, predictable, and dispatchable GETS solutions to improve our system. States and their electric utilities should explore these emerging technologies with as minimal ratepayer impact as possible. In the Southeast, the Southern Company founded Energy Impact Partners to provide venture capital to grid-related projects. Done with shareholder, not ratepayer funds, this R&D company can incubate new tech companies and innovate without ratepayer-funded R&D. Finally, planning, budgeting, and balance will give states and their utilities access to new technologies that will improve reliability and overall system resiliency. I'd like to close with a quote from Jay-Z, but I'm just not that cool.
Commissioner Clements again.
Okay. I like to karaoke, so maybe we could fix that later. So I think if we think about the barriers, the operational barriers, they can be overcome. And they will only be overcome if we fix the financial disincentive to further deployment. I forgot to say in my last answer, actually, a few utilities in PJM have been early adopters and done a lot of work with PJM related to things like, how do I deploy, use dynamic line ratings and still satisfy my NARUC obligations? And I just wanted to give kudos to the engineers at PJM because they did a lot of work with PPL, with Duquesne, with others in order to move this along so that other utilities can take advantage of it. But getting to the bigger problem, which is the financial disincentive, customers are the winners. Customers are the ones who win when we figure out how to widely deploy and optimize a variation of grid enhancing technologies. But in these planning processes, customers don't have the same constituency that transmission investment has, that market participants who have built up entire business models fairly around congestion, pricing, and the expectations around what that's going to look like. And so it's we can't fix that lack of incentive if regulators don't step in. And I forget who said this, maybe Chair Phillips, you said it, it's the other half of, it's how we do regulation, right? If it doesn't work to encourage utilities to do these good things because they don't make money doing it, then we need to help them make money doing it and help them to innovate. So I think, people have mentioned the shared savings opportunity that FERC has looked into. We've talked a little bit around the edges of performance-based rate making, which is something that could come into play here. The commission has statutory, not just, it has a responsibility, an obligation to incentivize advanced technologies on the transmission grid. And our Order 679 is pretty old. And when we're talking about whether or not any incentive is a good use of money, when you think about the opportunity to save the sums we're talking about, maybe helping to incentivize deployment of some set of cost-effective of grid-enhancing technologies would be a good use of that statutory authority and responsibility. I think utilities have led on innovation. I just mentioned a few in PJM who are doing this. So let's help facilitate broader adoption. And I take Commissioner Duffley's point very seriously. What's the cost allocation? I think a few things. The sums we're talking about are small enough that it allows for creative solutions, right? And in some cases, we were talking about the software components of grid enhancing technologies. They're not a one-time thing. They're not just for that investment. They apply and then allow to be used over and over again, especially on things like topology optimization. So those are things that when we get concrete about the numbers and the details, perhaps it lends itself to a cost allocation that people can get comfortable with. So to my mind, it's the biggest barrier is just the reality of how these economic incentives are set up, but we're not without opportunities to fix that problem.
And again, sorry, we're just gonna have to go to the next question, given time. So the last question is about the risks. So what are things that can or should regulators consider doing to address potential risks related to GETS? We're going to start with Chair Phillips and Chair Scripps, and then end with President Fiordaliso.
Thank you, Dr. Rob. I think, first of all, much of the risk have been talked about today. There are two things I'd like to focus on. I think the first is that we're dealing with unproved technology. I think, and just to put a fine point on it, it's fear. It's fear that we're going to overspend on GETS and that customers aren't going to get the benefit that they thought they were going to get. There's fear about who pays, cost allocation issue. There's fear about getting it wrong, because our utility industry is conservative, and rightfully so. Grid planners use a least cost option when they plan our grid. But if you do take a step back and you look at this holistically, if you don't look at it siloed, the way we do a lot of transmission planning around the country, it's obvious that there are benefits that need to be considered. So I think the first risk or the first hurdle as regulators that we have to face is just fear. It's fear. I think the second one is reliability, and a part of reliability is cybersecurity. I talk about it all the time. Foreign and domestic actors are constantly targeting our grid all the time. I think we need to realize that when we talk about new technologies, we're solving for the same cyber, physical, and reliability issues that we have to solve for on our traditional system. The only question is, do we want to keep doing what we've been doing and getting the same results? Or do we want to, in this period, and to President Fiordaliso's point earlier, and I think it's a brilliant one that needs to be underscored, the math is not mathing when you talk about the time that we have to get to where we need to go. And so I think we have to try new things. And if it means we have to solve for those same issues that we have to solve for on traditional facilities, we just have to apply that same framework, reliability standards, best lessons learned, best practices, making sure that we share information We can do this. So I won't say anything that's already said. I'll just focus on those two risks. Thank you.
Chair Scripps.
So on the specific question of what we should be doing to address risks, I think we've already done a fair amount of work. Commissioner Clements talked about a number of the things that have actually been tested and proven in the field. And within MISO, just on the AARs, if there's ever an interruption in receiving AAR data, the rating value defaults to a more conservative static or seasonal value, which addresses concerns that human error and forgetting to input the data or communications systems failures could possibly threaten reliability. So I think we've largely taken care of some of the operational risks. But the best way looking forward to overcome these risks is through increased data and information and transparency around that information. I think it was Commissioner Clements and Commissioner Frentz who talked about the value of learning from experience. And I think FERC has a role here in pushing to ensure that we have the information and data to inform best use cases. As a number of folks have pointed out, these aren't one size fits all. And in fact, within MISO, OMS has stopped short of saying FERC should require or mandate anything related to GETS because of that, but instead should encourage the use of dynamic line ratings and other grid enhancing technologies and develop a framework that would provide some guidance in areas where it was appropriate and useful to use grid enhancing technologies and where it is not. And I think that framework is probably what we're looking for. But transparency in the information, I think, is key, because without it, it's really impossible to determine the accuracy of what's been submitted, particularly given some of the conflicts around sort of the transmission owner submitted line ratings if we're deferring entirely to the owners of the system in terms of where we get the information. And as an example within MISO, some areas within the footprint don't have a single line with a unique emergency rating, while other areas have unique emergency ratings on a majority of the lines. And it just seems to be whether the work's actually been put in. But as of January 2021, 2/3 of the lines under MISO's functional control have emergency ratings that are the same as normal ratings. Is that accurate? Without greater transparency around data, and as long as we entirely defer to TOs to submit this information, it really is impossible to be certain. But on the flip side, with greater transparency around information, we can increase our confidence of how these various GETs will perform, increase our comfort in utilizing GETs, not just in responding to operational challenges, but also incorporating them into the planning process and unlocking the many benefits I talked about earlier. I've got more, but I know we're over, so I'm just going to stop there.
President Fiordaliso.
Thank you, Dr. Excuse me. President Franklin Delano Roosevelt, during a very difficult period of time in the history of our country, Depression, World Wars, and so on, in his fireside chats always said, the only thing we have to fear is fear itself. And to build on Chair Phillips' comment, that's all we do have to fear. As both Chair Phillips and Commissioner Christie know, the PJM RTO is a very diverse RTO. Some of the items that are important to New Jersey, as an example, may not be as important to West Virginia or some other state. I said this in my beginning comment. We can't be afraid to take risks. Risks are part of our daily life. As I said in the beginning statement that I made at the beginning of this summit, was that I tell staff every day, anything new that we embark on, we're going to hit potholes. We're going to face challenges. And we as regulators have to be willing to take those risks, because we are encountering and we are in the process of an energy revolution in the United States and in other parts of the world. It is indeed a revolution. We are altering, as we continue to move forward, how we generate energy. That's no simple thing. And people like Thomas Edison wouldn't recognize what we're trying to do. Happens to be done most of his work in New Jersey, by the way, just a little commercial point there. But it's vital that we are not constrained by fear. It is so vitally important that we move ahead and that we look at transmission in a wide variety of ways. I always like to point out that energy and energy generation and transmission, it's like a jigsaw puzzle. There are a lot of pieces to it. I'm not talking about a 25-piece jigsaw puzzle. I'm talking about a large jigsaw puzzle. And it's our job as regulators to fit those pieces together. And if we make a mistake, so be it. If we can't find where that one piece fits, eventually down the road, we will. So I ask my fellow colleagues, we know that there are risks, and there are ways to overcome those risks. And I think one of the ways is this task force. And I want to compliment FERC and NARUC for setting up this task force. Because the interaction between states and the FERC continue to improve tremendously. And this summit only enhances that. So by working together, by looking at a regional approach, our neighbor, which is New York State, and I live in North Jersey, so I'm in Manhattan in 25 minutes, barring traffic at the Lincoln Tunnel. And if there's not traffic at the Lincoln Tunnel, I get nervous that there's something wrong. But it's cooperating with our fellow states. It's cooperating on a regional basis so that the costs are spread out, which is beneficial to our ratepayers. But let me finish, and I hope I answered the question, that we cannot be afraid. We know what our mission is. We cannot be fearful of moving forward with this revolution that we are currently in. Thank you, sir.
Thank you. And thank all the task force members for all your thoughtful, prepared, insightful comments today. I'm really sorry that we did not have more time for back and forth as we have in the past. But it's 4:57, so I'm going to need to turn it over to the co-chairs.
Well, I'd like to thank all of you for the productive conversation today. I'd like to thank Dr. Robb and all of the staff that made this meeting possible today as well.
I want to echo those comments. Thank you, everyone. Thank you for coming. Please give us feedback on how this meeting went, the timing of it, when we had it. We will take that in consideration with leadership to come up with when and where and what we'll talk about the next time. So with that, I thank you so much. Commissioner Christie, I recognize you.
Welcome, Commissioner Duffley, as our new co-chair. It's great seeing both of you up there. Great choice. And I think it's appropriate, too, to recognize Jason Stanek, who served in this position for 2 years, and also to recognize, relative to what Joe Fortaliso said, Rich Glick, because, Rich sort of kicked this thing off, this joint task force. And so I think it was a great idea when Rich brought it up, and I'm glad we're doing it. I hope we'll make it permanent. I hope if Mike Caron's out there, we'll make this a joint FERC entity that ongoing and maybe expand the subject matter. It's a great reason for FERC commissioners to come to NARUC meetings. And I think it is a great vehicle for interaction, and so I hope maybe someday this will be a permanent, ongoing task force.
Not improve upon that, so thank you, Commissioner Chrissy, and that closes out our task force. Thank you so very much.